Question 1. Diagram shows the distance against time graph of a moving particle for 5 seconds. Okay, so first we highlight the keyword, which is distance against time graph. Okay, then we are asked to find the distance and also the speed. Okay, so distance against time graph. So to find the distance, you just look at the y-axis here. Okay, you don't need to do anything, you just look at this y-axis. The distance traveled by the particle from second to fifth second. Okay, so from second to fifth. So what's the distance traveled in between 2 to 5 seconds? So 5 seconds is 20 meters. 2 seconds, the car travels 15 meters. So just minus 20 minus 15. So 20 minus 15. So the answer is 5 meters. B. The speed of the particle for the first 2 seconds. For distance against time graph, if we want to find the speed, then we have to look for the gradient. Okay, because distance against time graph, the gradient will be the speed. Okay, so we just find the gradient. So we just find the gradient for the first 2 seconds. Okay, so 0 to 2. So we draw a triangle. Okay, so we're going to take these 2 points. The coordinate of this is 0, 0. The coordinate of this one is 2, 15. Okay, then we find the gradient, which is 15 minus 0 over 2 minus 0. 15 over 2. So the answer is 7.5. Speed, the unit for speed is meter per second. You also have to look at the graph here because this is meter, so you write here meter. If here is kilometer, then you have to write kilometer. Okay, then the unit given for time is second, so we write per second. Okay, question 2. Diagram shows the distance against time graph of a moving car for 12 seconds. Okay, so we highlight the keyword distance against time graph, and we have to find the average speed. Average speed. Okay, so the formula for average speed is total distance divided by total time. A. The value of V if the average speed of the car for the first 6 seconds is 2 meters per second. So first 6 seconds, so 0 to 6, 0 to 6 until here. Until this one. You are given the average speed is 2 meters per second. So this is the formula for average speed. So use this formula. Total distance. So what's the total distance traveled in this 6 seconds? V. Okay, so we write down V over total time. 6 seconds. V over 6 equals to, you are given the equation here. So 2 meters per second equals to 2. So V equals to 12 meters per second. B. Find the average speed of the car for the first 8 seconds, means from 0 to 8. Okay, so average speed, we use the same formula here. Total distance over total time. So 8 is here, and here this one. So the total distance traveled is 15 meters. So 15 divided by total time, 8 seconds. So divided by 8. Then you will have 1.875 meters per second. Question 3. Diagram shows the distance against time graph for the journey of a train from one town to another for a period of 90 minutes. Okay, so we highlight the keyword. So the keyword will be, this is a distance against time graph. Then we are asked to find the duration of time during which the train is stationary. Then we are asked to find the speed and also distance. Okay, so we start from A. For a distant time graph, when the line is a flat line, that means this object is not moving at all. Okay, so if you have a line going up with a positive gradient, okay, that means the object is moving. Then if you have a negative gradient, you have a line going down, that means this object is still moving but in opposite direction. Okay, so for part A, we are asked to find when the train is stationary. That means you have to find the flat line. So here's the flat line. So what is the duration of time? So 40 minutes until 65 minutes. So A, 65 minutes minus 40 minutes. then you will have 25 minutes. So the train stays stationary for 25 minutes. Stationary means does not move at all. B. Calculate the speed in km per hour of the train in the first 40 minutes. Okay, we have to be careful of this unit also. So the question asks us to find in km per hour, but the graph given here is km per minute. So we have to change minute to hours. Okay, so for first 40 minutes, let's consider this one. So we take 2 points, then we draw out the triangle. The coordinate of this point is 0, 150. The coordinate of this point is 40, 90. Okay, we have to find the gradient. So 150 minus 90. This is in kilometer over x2 minus x1, 0 minus 40. Okay, here's the problem. This is in minute, but the question asks for in hour. Therefore, we have to divide it by 60. Okay, because 1 hour, 60 minutes. Then here you have 60 divided by 0 minus negative 40 is negative 40. Negative 40 divided by 60. Then you will have negative 2 over 3. So 60 over negative 2 over 3. The answer is negative 90 kilometer per hour. Negative means the train is moving but in opposite direction. That's all. Okay, C. Find the distance traveled by the train for the last 25 minutes. So what is the meaning of last 25 minutes? Okay, so this one, 65 minutes until 90 minutes. This is the last 25 minutes. Find the distance traveled. So at 65 minutes, the train is at 90 kilometers. But in 90 minutes, the train is at 0 kilometers. So we just minus 90 minus 0. 90 minus 0. You will have 90 kilometers. Number 4. Diagram shows the speed time graph of a moving particle for 10 seconds. Okay, so we highlight the keyword, which is this is a speed against time graph. Then we are asked to find the total distance, the average speed. Okay. So for speed against time graph, what information can we gain from speed against time graph? Okay, so from the summary here, for speed against time graph, if we find the gradient, then we will get acceleration. If we find the area under the graph, then we will have distance traveled. So we back to the question here. The total distance traveled by the particle for the whole journey. So for part A, to find total distance, we just need to find the area under the graph for the whole journey. So we need to find the area of this. So this is a triangle. So we just use the formula of a triangle. Okay, so let's say this is the height. So the formula of triangle is 1 over 2 multiplied with base. Base is 10 times height. Height is 15. So the answer is 75. Okay, total displacement or total distance, so meter. So this is the answer for part A. For part B, the average speed for the whole journey. Still remember the formula for average speed? Total distance divided by total time. Okay, total distance we have calculated in part A, which is 75 meter over total time. The time travel is 10 seconds. So the answer will be 7.5 meter per second. Question 5. Diagram shows the speed against time graph. Okay, so we highlight the keyword, which is speed against time graph. Then we have to find the length of the time. Move with uniform speed. The distance traveled. When it moves with constant speed, the distance traveled by the particle when the rate of speed change is negative. Okay, so this is a keyword, constant speed when the rate of speed change is negative. Okay, so for speed against time graph, have a line going up. That means this object is accelerating. Accelerating. Its speed is keeping increase. Then if we have a flat line, the gradient is 0. That means this object is still moving but with constant speed, with the same speed. Constant speed. Then if we have a line going down, negative gradient, that means this object is decelerating. The speed of this object is decreasing. Okay, so for part A, the particle move with uniform speed. Uniform means constant, so we have to look for the flat line. So here's the flat line from 6 seconds to 10 seconds. So the length of time will be 10 minus 6. 10 minus 6 equals to 4 seconds. B, the distance traveled by the particle when it moves with constant speed. Okay, so constant speed is here. To find the distance traveled, we have to find the area under the graph. So this is the area under the graph, rectangle. So we use the formula for rectangle. Rectangle, length times width. So the length is 4 times width 10, 40 meter. This is for part B. For part C, the distance traveled by the particle when the rate of change, speed change is negative. Rate of speed change means accelerate. Accelerate is negative, that means this particle is decelerating. So decelerating means negative gradient. So this part, the part where the line going down. So we have to find the distance traveled. So for C, we have to find the area under the graph for this part. So this is a trapezium. To find the area of trapezium, the formula is 1 over 2 times the sum of parallel sides. So this and this. The length of this one is 25 plus this is 10. Then multiply with the height 6. Then you will get the answer 105 meter. This is for part C. Question 6. Diagram shows the speed time graph for the movement of an object. Okay, highlight the keyword first. Speed against time graph. We have to find the duration of time, uniform speed, the rate of change of speed, calculate V, the value of V, total distance traveled. So for part A, uniform speed, okay, same as question 5. For uniform speed, we have to look for the flat line. So the flat line is here. For 15, from 10 seconds to 28 seconds, we have to find the duration of time, so just minus 28 minus 10. 28 minus 10, you will have 18 seconds. B, calculate the rate of change of speed. Okay, this is acceleration in meter per second for the last 12 seconds. Okay, last 12 seconds is from 28 to 40. Okay, so for this one, we have to find the gradient. So we take these 2 points. The coordinate of this point is 28, 15. The coordinate of this point is 40, 0. Then we just find the gradient. 15 minus 0 over 28 minus 40. Then you will get the answer, negative 1.25 meter per second. C. Calculate the value of V if the total distance traveled for 40 seconds is 500 meter. Okay, so total distance for speed against time graph, this is area under the graph. So that means the area under the graph of this equals to 500 meter. So we divided this graph into 3 parts. This is A, this is B, this is C. Okay, so the area of part A, this is a trapezium. So you will have 1 over 2 times the parallel side, V plus 15, times with the height 10. Okay, this is the area of part A plus area of part B. This is a rectangle. So 18 multiplied with 15 plus area of C. This is a triangle. So 1 over 2, 12 times height. The height is 50. And you are given the total distance traveled is 500. So this equals to 500. Okay, then you solve this one. Okay, we can simplify 5, then multiply in 5V plus 15 times 5, 75 plus 18 plus 18 times 15, 270 plus, okay, simplify this one, 6. 6 times 15, 90 equals to 500. You rearrange the whole equation. So 5v equals to 500 minus 75 minus 270 minus 90. 65. So v equals to 65 divided by 5. You will have the d. 7. Diagram shows the speed against time graph. Okay, again we highlight the keyword speed against time. We have to find the speed at t equals to 9 seconds. The distance traveled by the object. Okay, distance traveled. Okay, A is very easy. When t equals to 9, so just look at t equals to 9, then you draw a line up until you touch the graph. Then this is 6 meters per second. So the answer is 6 meters per second. That's all. For part B, distance traveled. For speed against time, when we need to find distance, we just find the area under the graph. For the first 12 seconds, so until here only. So we have to find the area under the graph for this part. So this is a triangle. So half times base 12 times height 8. 48 meters. 8. Diagram shows the speed against time graph of a moving object for 15 seconds. Okay, highlight the keyword speed against time. Find the time interval with constant speed. Find the acceleration. State the time when the object is stationary. Okay, so constant speed means flat line. So here's the flat line, this one. Okay, this is from 6 seconds to 12 seconds. So just minus 12 minus 6 equals to 6 seconds. B, find the acceleration from t equals to 6 to t equals to 12. 6 to 12. To find the acceleration from speed against time graph, we have to find the gradient. So this is a flat line. Acceleration equals to 0. You can just write it down, 0. Or you do not know this, then you can find. Okay, this is the coordinate of this point is 6, 6. The coordinate of this point is 12, 6. Therefore, the gradient will be 6 minus 6 over 12 minus 6 equals to 0 over 6 equals to 0. Okay, you can show this, or you can just straight away put this down. For C, state the time when the object is stationary. Stationary means does not move at all. So, when the speed, that's me, the speed of the object will be 0. So this one. At 15 seconds, the speed of this object is 0. So the answer is 15 seconds. Question 9. Diagram shows the speed against time graph. Okay, so again, speed against time graph. State the duration of time. Uniform speed. Calculate the rate of change of speed. Calculate the value of u if the average speed is 6 meters per second. Okay, so 17 for A. Uniform speed means we have to look for the flat line. So here's the flat line. From 20 seconds to 26 seconds, so 26 minus 20 equals to 6 seconds. Calculate the rate of change of speed. So this is acceleration. To find acceleration from speed against time graph, we have to look for the gradient. Okay, for the first 8 seconds, so until here. So we mark 2 points. The coordinate of this point is 0, 10. The coordinate of this point is 8, 6. Okay, so for part B, we just need to find the gradient. 10 minus 6 over 0 minus 8 equals to 4 over negative 8 equals to negative 1 over 2. Negative 0.5 meter per second per second. Okay, this is square, not cube. Okay, C. The average speed. Okay, when you see the word average speed, the formula of average speed is total distance against total time. For the last 26 seconds, so last 26 seconds will be 8 to 34. 8 to 24. 8 to 34 is the last 26 seconds. Then we have to find the total distance first. So how to find total distance from speed against time graph? We have to find the area under the graph. Okay, again, we divided this area under the graph into 3 parts. This is A, this is B, and this is C. So for part A, this is a trapezium. The area will be half times the parallel side 6 plus U, 6 plus U, times the height 12, plus area of B. This is a rectangle. So 6 times U, 6U, plus this is a triangle. So half times the base here is 34 minus 36. 8 times height U. Okay, so this is the total distance divided by total time. Total time is 26 seconds equals to average speed equals to 6. Okay, then you just solve this one. So, okay, simplify this one to 6, then 4U. Okay, so you will have, after that you will have, okay, multiply. So 36 plus 6U plus 6U plus 4U equals to 26. We move to right hand side, so we multiply 6 times 26, 156. 6U plus 6U, 12U plus 4U, so you will have 16U equals to 156 minus 36, 120. So U equals to 7.5 meter per second.